Welcome to the Troxel Podcast. I'm Evan Troxel. This is the podcast where I have conversations with guests from the architectural community and beyond to talk about the coevolution of architecture and technology. In this episode, I welcome Stefana Parascho. Stefana is a researcher, architect, and educator whose work lies at the intersection of architecture, digital fabrication, and computational design. She is currently an assistant professor at EPFL, where she founded the Lab for Creative Computation, also known as CRCL. Through her research, she has explored multi-agent fabrication methods and their relationship to architecture. Her current research focuses on human-robot collaborative processes and the relationship between robotic construction and the built environment. Her goal is to strengthen the interdisciplinary nature of the field by increasing accessibility of digital tools and connecting technical research with societal aspects. Before joining EPFL, Stefana was an assistant professor at Princeton University, where she led the Create Lab Princeton. She completed her doctorate in 2019 at ETH Zurich Gramazio Kohler Research. Previously, she received her diploma in architectural engineering from the University of Stuttgart and worked with Design to Production Stuttgart and Knippers-Helbig Advanced Engineering. In this episode, we discuss the increasing accessibility of robotics in architectural education and industry, as well as the need to consider the long-term impact and trajectory of the field. In her role as professor, she highlights the excitement and formative experience for students to participate in the ideation and fabrication of precise and complex structures. We also talk about her background in architecture and her experience with computational design, robotics, and her current work with multi-robotic assemblies. Ultimately, Stefana envisions a future where robots are working alongside us as coworkers with the ability to execute smaller tasks and communicate with humans in a more intuitive way. So without further ado, I bring you my conversation with Stefana Parascho. Stefana, welcome to the podcast. Great to have you.
Thanks for having me.
Can you give us an origin story of where you're coming from and a bit of your backstory leading up to where you're working now?
Sure. So I am educated as an architect. I actually started my studies in my home country in Romania, where I studied for 2 years, after which I moved to Stuttgart, to Germany, and I finished my studies there. So I got my what counts as a master's degree nowadays. It used to be a diploma degree. I'm that old that things have changed in the time. But I got that from Stuttgart, so from Germany, and that is where I first got in touch with computation, computational design, robotics, any sort of new digital tools that were up and coming in architecture and in the design scene. I studied there with professors Achim Menges and Jan Knippers, and I think I overlapped at, I want to say at the right time. For me, at least it was the right time, because it's really when the ICD, the Institute for Computational Design, when it got founded. And it started back in Stuttgart. That's when I was a student there. So I got to be part of the first studios, the first courses. Really, it was all super duper new to me and everyone around the school. But it really opened up a new niche and, yeah, an interesting corner of an interesting new field that I wasn't fully aware of beforehand during my architecture studies, and it definitely got me hooked. So I finished my architectural degree there in 2012, and then I worked a little bit in practice for a few years in engineering offices and in consultancies, geometry consultancies for architects, so more on the software side, programming, solving geometric issues. And then I went to Zurich to do my PhD. So I did my PhD at ETH Zurich with Gramazio Kohler Research. They were really, and still are, really focused and specialized on robotic construction techniques. So that's kind of where I focused or narrowed it down on robotic assemblies. In my work, specifically multi-robotic assemblies. And then I finished my PhD in 2019, and I was at Princeton University for 3 years as an assistant professor. So I was teaching and doing some research there. And then now it's been a year that I came back to Switzerland. I moved to Lausanne in the French-speaking part of Switzerland, and I am an assistant professor at EPFL in the architecture department, still doing what I do best, working with robots. So focusing on robotic construction methods, we're specifically also looking at human-robot interaction, multi-agent systems, where we can employ robots for design and construction, and what the relationship with the human, with designers, with builders is, and where we can take this technology from now on. That's basically what I do right now.
Nice. There's a
Yeah.
lot there. And I'm wondering, with robotics in academic scenarios for architecture, can you paint a picture of what kinds of robots you're using? You're talking about multi-robotic assemblies. I mean, from that word structure alone, it's like a concert of robots working together to do something, right? And so maybe you can just give the audience an idea and me of what that actually looks like.
Sure. I want to say in architecture, we mostly work with industrial robots for different reasons. One being because they're very widely accessible. They're easy for us to get. They're, I want to say easy to use, but of course they're not like super intuitive to use for anyone. You need a little bit of skill build up, but they're not the most complex machines out there. They're actually just a ton of steel and some motors. They don't have a lot of intelligence, but they are accessible for us. They're versatile. Basically, you can put whatever tool you want on top of them and then make them do what you want to do. But the other reason also is because we're not roboticists ourselves. So we don't really develop our own machine. Not to exclude that sometimes we hack machines, we try to come up with new solutions, but we typically rely on robots that are somewhat available, that we can get easily and we can start working with. So that's why we mostly work with industrial robots, but we are always, and I say we because I generalize for most people in my field. I do mean me, but I think we get easily excited about all types of robots. So it's also really nice to work with other types of machines, but we need that input from, say, people who really develop the machines. And then, when I do say multi-robotic assembly, it sounds like many robots. It's always good to start small and to increase complexity over time. So I mostly work with 2 robots. That's what I call multi. But looking into the reason for me why I did stick to, say, one machine coming up with a process, but I thought about several of them, is that they can start taking on different tasks, different roles. They can start supporting each other. And it opens up a whole lot of possibilities that goes beyond like just 1 + 1 robot equals 2. But all of a sudden, you can do a lot more complex tasks, and you can really think about what their roles are. How can those change? What are benefits? What are things that you can do with 2 that you can't do with 1?
Right. I'm always remodeling something in my house, and oftentimes I find myself alone holding something up over my head or maybe using my head to hold something up while I'm drilling with my right hand and, I don't know, steadying myself with my left hand. And I can only imagine how the robots can do so much more just by adding one more arm, right? And that idea of working together to accomplish, I don't know, bigger things, better things, whatever, it seems obvious, right? But I can only imagine the coordination that has to happen between those two so that they don't clash. It becomes kind of an art in itself of just programming those movements or sensing those movements in real time. I don't know, maybe you can kind of explain how that works, because I can only imagine the expensive mistakes that could happen with clashes in robotics.
Yeah, that's a good point. You found the perfect example of what one can do with several robots, because that's literally what we did. So I used 2 robots to allow one to hold and support a structure, and the other one to bring a new element. So they would alternate, and you always have one robot that acts as a support. So it's pretty much like what you were describing, though, using your head, but instead get a robot. But it's true. Yeah. So it comes with many challenges. It sounded relatively straightforward at first, but then you get into it and bump into, I want to say challenges that were also because of myself being an architect. I mean, I don't want to blame it or generalize that architects don't have the skills and knowledge of roboticists, but we don't. I mean, we just have a different background. So that's a lot of things to learn on the go and figure out solutions without having that strong foundation in robotics. So the main problem really was avoiding collisions between robots, between the robot and the structure that is changing at all times, and figuring out the robotic movements. Yeah, I don't want to get too technical, or I don't know how technical you would like me to get. I can, but like the main issue with an industrial arm is that it has typically 6 joints. They're rotational joints that are linked one after the other. And the issue is if you want the tool to go from A to B, you can tell it go in a straight line from A to B, but you have absolutely no idea what the body of the robot will do to reach that point. So it kind of has complete freedom, or the controller, the robot controller typically calculates that movement. And you don't really know where the elbow of the robot goes, where a certain, whatever part of it will go and what it will hit. So just imagining and thinking those movements through the way that we do as humans in a 3-dimensional space, where it's just like, oh, I want to go from here to here. It doesn't really work with robots. You just don't know. It's impossible to intuitively tell how it will move. So that turned into a challenge in itself. I collaborated with colleagues also within architecture. We worked a little bit with the roboticists, I want to say, at the very beginning, to bring in algorithms that exist in robotics for path planning. So it's nothing new that had to be invented, but we don't have those in our own environment. So in CAD or in any sort of modeling environment that we would use to model and test the things that we want to build, we don't have access to those algorithms. So a big part of the work was connecting to these other tools that are out there and being able to use them to, in that case, to compute paths that are collision free, that can go from where the robot is to where I want it to be without knocking anything over.
Right.
None of it is foolproof, obviously, like nothing is. So they always are based on some form of approximation or on a certain resolution at which you calculate the robot's position. So actually a lot of avoiding collision was also just staring at the robot, watching it move, going from A to B, and hoping that I react quickly enough in case it is going to knock something over.
So you can hit the kill switch, the button to stop it right immediately.
Yeah, exactly.
Yeah.
I mean, we work with it in manual mode, meaning we don't even need a kill switch or an emergency stop, but you constantly have to keep a button half pressed, which sounds very uncomfortable and is. Just so in case anything goes wrong, you just let go of that
Just
button.
let go. It's easier to let go than to push. Yeah.
Yeah, exactly. Yeah, exactly. But that means you're cramped. You have your hand constantly stuck in this in between position for days in a row.
It sounds like the perfect job for a robot. Yeah.
Yeah, exactly. I know. I know, and not official talk here, but students have come up with very creative solutions to not having to hold their hand on that button.
Well, and I mean, what's the worst that can happen? If somebody actually gets too tired and they let go, the robot just stops and it's okay, right? Yeah.
Yeah, exactly.
So if they're cramping up and they need a break, they can just let go and pause the situation for a little bit.
Exactly. Can always take a break. That's true.
So with your work, can you explain the types of conditions that you're exploring for the work that the robots are doing? Like what kind of construction? You talk about robots working in construction. What are the things that are going on? Because I think back to the early 2000s, 2010s, when every pavilion was out there that was being assembled by robots using, I forget, it was like carbon fiber, right? And it would cure in the air. And every pavilion was kind of this, the shape of it was completely defined by the scope of the robot's movements, right? It was like it can't collide with anything. And the sweep of the roof arc was like what the robot could reach, at least, and I'm sure there was obviously some design intent going on in there too, but it was working with a heavy set of constraints to create the forms that they were creating with those. And I'm sure a lot of that was done at ITG Stuttgart, right? And that work was being figured out there in real time and even in the public, which I think was kind of cool, like doing it out on display and having these pavilions built and out there for people to see. But I'm just thinking about now when you add one more robot to that situation, the forms that it can do are completely different. So I'm just wondering, like, what are the types of ways in which you're using the robots to help or aid with construction?
Yeah. I mean, you pointed it out very clearly and precisely how things went down. Also, that was during the time that I was at Stuttgart myself. Okay. So I'm very familiar with those beginnings and the pavilions that we all built back there. And it's part of how my work went too. So I generally don't work with a specific material. It's not that I have a fascination for one specific
Mm.
material that I've been studying in depth and really, find it in all my work, but I'm a lot more fascinated by the process itself and figuring out what robots can do for all sorts of different processes and materials. So I did work in my PhD, I worked with space frame like structures. I call them space frame like because technically they don't fulfill the definition of space frames where all the bars meet in one point in a node. So, anyways, it was a whole conversation at my PhD how to call them,
Mm.
but space
Hmm.
frame like structures made of metal rods with the intent of generating geometries with a lot less regular arrangements of the members. So members could have different dimensions, different orientations, different positions. You can have a lot different numbers of elements come together in one node and all of that. So basically to free up the possibility of design there. And this, I think, kind of lied at the base of most explorations that happened in those first 10 years or something of robotics in architecture and design. There was a lot of excitement about we can build geometries that are not buildable without those machines or that are really difficult to build by hand. So these machines allow us to design and to build completely new things. So a lot of the explorations that I did went in that direction too. I do think at this point, right now, as I'm leading a lab and I have students, PhD students working here, and we're constantly discussing and wondering where is this going? Like the field has now existed for quite some years. I want to say almost 20 years, quite clearly existed. And before, not that before there was nothing being done with robots, but like really established field of robotics and architecture. And it is a bit of a question. Okay, we can build all sorts of pavilions. They allow more formal exploration than without these machines, but they come with a very, very intense set of constraints, as you pointed out. So like where are we really going? What we're trying to look into is making processes more adaptable, making them more accessible, easier to use, easier to implement, to be able to work with them just in a more intuitive way, in a more natural way, and keeping that connection between the human and the machine. So a lot
Mm.
of the work that was done, it required a separation of human and machine. You had to define the geometry very precisely. You then figured out all the paths and how it had to move. And then you execute it. Of course, there's humans outside and nothing ever goes as planned. But the ideal would have been, oh, the robot does it perfectly without the need for humans. I think that works really well for very special cases of construction and for those pavilions. Yeah, it works really well. But I do wonder what it takes to see robots being used a lot with a lot more ease and simpler, just an easier use of robots in construction, on site, in wherever you need them.
Hmm.
I think it's this connection with the human that one can work with them together. One can kind of almost decide on the spot, hey, can you help me with this? I need to screw this beam in here. Can you hold it here? I learned some form of communication and of interaction and adaptability without needing to predefine every single move that the machine does.
Right.
So that's a little bit of things that we're doing here or discussing here. It's a new lab, so we're setting up a lot of things. There's more talk than results at this point.
Okay.
But these are really the questions that we're asking ourselves. Yeah.
It seems like the idea is you want to get it to a point where it's like using a printer, right? Because that's how, like, all of these
Yeah.
technologies that have led to this point, like, that's what's happened. We saw that happen with laser cutters. We saw that happen with 3D printers,
Yeah.
where you feed it the desired output and it performs that. And you have to think less and less over time of all of the steps that it takes to get the motors to do
Right.
the thing that you want, and setting the power level for the laser and telling it to do this before that, because if you don't, it's
Mhm.
going to fall through and it's going to burn the model or whatever. Like, all of those things are the things that slowly get removed from the system. Like, thinking way back to the idea of PostScript and laser printers, right? And desktop publishing. It was like, before that, it was such a crazy chore to go through to set up your document to do that. And then
Mhm.
finally, it got to the point where I could just like design it in Quark Express or PageMaker back in the day, right?
and it would actually print out what I designed without any knowledge of all of the systems it took to actually do that, right? And so with robots, that's the goal, right? Well, you tell me. Yeah.
Honestly, yes, but not quite. Yes, in terms of control, in terms of telling it what to do, ideally, there's an easy way of telling it what to do, and it really understands and then just performs it. But the what to do, I think, is very different between robots and most other tools that we've had before, because robots don't have a specific purpose. They don't have one tool,
Right.
one action that they do, that they're made to
Mm,
do.
yeah,
They're
I see
just
that.
an arm, right? So
Mhm.
the things that it can do, it's basically an infinite set of possibilities. So I think if there's another step of how do we translate or how do we communicate, how do we first figure out what would be a good thing to do and how do we communicate that to the machine? So for me, the difference would be rather than designing something and then telling the robot, hey, make this happen for me. I think it can be broken down into a lot smaller tasks. And
Mhm.
then you can really work with the machine almost like you would work with a coworker, although the machine has different capabilities. But the ideal scenario would be you have your little helper robot with you and you can kind of ask it for small tasks, small things of, okay, what do we need to do now? We need to screw this. Or what do we need to do? We need to figure out the right sequence of how to assemble all of these things together, which is not something that a human can intuitively very easily do. But hopefully, if that can be translated into a task for the robot or the computer behind the robot, like those tasks can go from screw in a screw to plan something for me. But I think that's flexibility and versatility. If we could find a way to communicate and to control that so that it's not a fixed set of what is an appropriate task for a robot, is it a big task, is it a small task, but that it can somehow have flexibility in between, that would be pretty awesome and really complicated.
I want to
But
get
yeah.
to the part where we talk about contractors in this equation, but I don't want to go there
Yeah.
yet because what just went off in my brain when you were talking about this is the rise of ChatGPT and natural
Yeah.
language as a
Yeah.
driver, right? As like
Yeah.
this great UI
Yeah.
for driving whatever the computer, right? For driving the computer. And
Yeah.
so this with robotics, where do we stand right? I know this is like what we would say early days for this, right? But are you really excited with the developments in this AI side of, the chatbots and what it can do to summarize information or break a complex thing down into actionable steps? I would assume that there's some pretty exciting application for that with robotics because the UI is something that everybody can understand potentially.
Yeah, I am. I am really excited about what's going on there. I do think it's like you said, at this point, it's really the very beginnings. But the most useful thing that I've seen so far with anything ChatGPT related is writing code. So actually not
Mhm.
having to write code yourself, which
Mm,
already burns down an accessibility barrier that was
right.
huge for anything. And like that, I can see happening quite soon for robots in terms of how do I program this particular machine.
Right.
The difficulty still remains that there's so many levels of what one needs to define before even getting to the point of how do I translate that into code. So yeah, what should my robot do? What is
Right.
its role in the first place? How do I then translate that into, is it the movement? Is it an action of the tool, say open a gripper, close a gripper, or do something? That there's so many steps before actually developing that code. So I think it's just a matter of layers of communication until you can break it down into that. I mean, I am very curious to see if and when that might become possible through something like a natural language processor. Yeah, it's a bit hard. Like whenever we think about this, the first step is define things very specifically, define the actions that the robot can do. And like getting rid of that step right now feels very difficult,
Mm.
unrealistic to say.
Mm.
Like I wouldn't know how what would we base it on. But I don't want to say it's impossible. Like
Yeah, it's
be
incredible to
like
see how
that we
fast
know.
things have evolved with even
Yeah,
just the
exactly.
GPT stuff. And so I can imagine that your gears are really turning in your brains over there of how it applies and how it changes the approach. Because to me, that's where these big step changes happen, right? Is actually in the approach, not even necessarily the
Yeah.
execution, but it allows you to think differently about how you approach the problem solving. Because now, like you just said, I don't even have to learn, quote unquote, to code. I can ask it to write the code for me, and that removes a huge step of the process, which completely changes how and who could approach solving the problem. Because before, that was something you had to do, it was a requirement. And now it's like, well,
Exactly.
okay, you don't have to do that anymore, right? Now the computer is doing that part for you. Again, you're going to double check it. You have to have some knowledge of it so you can make sure, because
Yeah.
again, mistakes are going to be expensive here.
Yes.
But this is getting solved over time, and this is a step on that new path, which wasn't previously there. And it's got to be really exciting.
No, it is. It's always a better question of maybe trust or mistrust.
Mm-hmm.
And a question of, okay, if everybody has access, or theoretically, if anybody could have access to telling a robot what to do, will this lead to something useful, or will it just lead to a lot of random things happening because people don't
Right.
think anymore about the foundations of what can a robot do? Where does it make sense? What do I need? Yeah, like you said, you need some knowledge still to turn it into something useful. Maybe it's a little bit, at least in my head, it's a bit comparable to what happened with parametric design when Grasshopper came out. It's like all of a sudden anyone can move a slider and
Mm-hmm.
make all sorts of geometries, but how much of that is in the end really useful? It kind of gets
Yeah.
diluted,
Every
and you're like,
Well,
what is going on here?
everybody's got a Voronoi pattern nowadays, right? So
Exactly.
we went through that phase
Yeah.
because of what Grasshopper enabled people to be able to do. But I do also think that there's this, I mean, you're in an academic setting, and like you said, you kind of distill this down to this, you analyze every little aspect of it. And then I think of my kids who don't know what a file system is. They don't even use email, right? And so you think about using
Right.
computers and how fundamental it is to like know where to put your files and how to organize them. Why? Not so that you need them now, but because you're going to need them in 3 years from now. And where do you find it? And that just doesn't even exist anymore for kids. It's like, what's a
Right.
file? What do you mean? Like, I don't, it's just in my app. I don't need to think about that. And it's the same way with like Google search. Go out there and start searching for something. And before Google, it was all directory based, right? And it was organized in a hierarchy. We had Yahoo, we had Alta Vista, and we're doing a lot of nostalgic things in this podcast episode. It's funny. I didn't expect that to happen, but it's like everything was a directory, and you would drill down and drill down and drill down. It was very much based on that file structure, that hierarchy. And again, like that just doesn't exist anymore. And now with ChatGPT,
Yeah.
you don't even need to go
Yeah.
to Google if you're looking for an answer.
Yeah.
Let's just disregard the part where the answer could be wrong right now, but
Right.
it could also be wrong on Google, right? The right answer could be on page 4, not on page 1. So it's really interesting to me because we still kind of hold these assumptions that we need this underlying structure, and what if, anybody could do this nowadays? And it's like life goes on, right? Just
Yeah.
it does continue. It's so interesting to me to watch that happen and acknowledge
Yeah.
that that's happening, even though like it's not how I learned, and it's not how I would even tell someone else how to approach learning to do that thing, because I don't know this new way. I know this old way. So it's fascinating to me that not only does this open up a new approach, but it's like the old approach is almost like non-existent anymore. And
Yeah.
it's not to say that there isn't a gradient there. There absolutely is. I think it's all fascinating to kind of watch from the sidelines. But people who are embedded in the 20 years of robotics research, like they're not going to think about solving the problem the same way somebody who is going through school now with fresh eyes with a chat GPT at their fingertips.
Yeah.
Like that is a completely different scenario. I think it's fascinating.
No, I totally agree. That's what keeps me really excited about it. I'm not the biggest fearful critic of it, as I see some of my colleagues be, but I am really, really excited just because it's new and it's different. And what will it do with the way that we used to work? It's super nice to see.
Well, and you're at the forefront of where those sparks happen. I think that, like you said, you're so excited about it, and to watch students ignite these ideas and to ask questions like they're 5 years old because it's all brand
Yeah.
new to them. It's got to be such a fun place to practice.
Yeah. I did. I mean, last year, no, not even a year ago, but maybe like 8 months ago, I was teaching my students how to program in Python, and
Mhm.
now I'm wondering if I need to still do this, if
Right.
they can use
Exactly.
ChatGPT. Literally,
You
it's
are
crazy.
literally following in the footsteps of every architectural program out there that used to teach how to use tools, right? It's like
Yes.
because I used to do this. I used to teach Form Z and then I taught ArchiCAD and then I taught
Mhm.
Revit. And then the schools were like, forget this. We can't teach. We don't have time to teach
Yeah.
these to the students anymore.
Yeah.
There's so
Yeah.
many resources online, they can just figure it out. So they actually just offload that responsibility to the students themselves. And now you're doing that because you can, right? It's like, what could we fill our most important subjects and time with if we don't have to fill it with that anymore, right? I think that that
Yeah.
is a very
Exactly.
interesting thing to stay atop of. Yeah.
No, definitely.
So
Yes.
on the contractor side of things, I'm wondering how and if, well, let's start with if, is there any coordination or collaboration with the build side of things? I think it's so interesting that all of the people, and maybe it's just because this podcast focuses on architecture, but that all of this is coming from the architecture side. The subjects that we've talked about with robotics in relation to architecture and construction all come from people who started out as architects. And
Mhm.
so can you tell us like what's going on that side? Because I imagine that there's also some fear there, like that's coming to take our jobs, but also there's probably some huge potential there. I know that there's some uptake of robotics, like especially on the 3D printing side in construction, right? As far as like being developed from the contractor side to deliver product. So maybe you can talk about that side of things because you're in an architecture school, but is there exposure with students to the construction side too? Because it's like, yeah, you can imagine designs, but when you actually have to build designs, that is something else. And then there is a wealth of knowledge on the construction side that the architecture side doesn't necessarily have. So
Mhm.
what is that collaboration like?
Yeah, I have a lot of thoughts on this. I have to structure them in my head. But I mean, maybe to begin with, I think I'm in a very luxurious academic situation
Hmm.
where I am really free of the, say, demands of the industry, and I can develop things that are interesting to me for a, of course, there's a reason behind things. It's not just that I wake up in the morning and I find this interesting. It does lead to the fact that I think my research is a little bit more on the fundamental side. And it's far away from what actual fundamental research is. Like, we're not doing mathematics, solving some sort of, I don't know, questions within numbers that we don't know where to apply it. It still has an application. But I get really excited about the possibility of what if we could do this? What if we could do that? And because I am in my luxurious academic position, I can be very critical of the industry. So rather
Hmm.
than catering to their needs, I can be okay, the industry has a lot of issues. It is maybe not moving in the whatever one would consider the right direction, say, with regards to dealing with the climate crisis, dealing with social issues, workers' conditions, etc., etc. So I can be a little bit on my high horse and be like, "You're all doing it wrong." I can criticize you, and I'm not gonna offer you solutions for what you want, which is to be more efficient, more cost efficient, faster, to
Hmm.
build
Hmm.
more, build cheaper, make more money. So that's where it's always a bit of question where we engage with industry and in what way can we get that knowledge out without being the ones catering to maybe what we see as problematic ourselves. And I try to do that. I mean, it's not that I don't work with industry at all. I do look at what's going on and what could be improved. But that's, for example, one thought where this close collaboration between workers and machines comes from. It's less about making it more efficient, making it cheaper, making it faster, but maybe about making it safer. If you have a machine that can take over tasks that are really not great for workers' health, that might be a bit dangerous. I mean, these are really big statements. Don't take them too literally, but maybe it can make it more equitable. You can have people work on construction sites that maybe don't have the, say, physical capabilities of a 1 meter 80 tall, strong men, but you have a
Mhm.
machine that can make up for this. And yeah, and maybe it can make it more creative, like less that everything needs to be predefined and you execute, you're a small part, you execute a task that's been assigned. But if you have a partner, be it a robotic partner that can kind of take over certain parts, that gives you more adaptability, that allows you to react and just be like, oh, let's try this, let's try that.
Yeah.
It's somehow how I would imagine this in a bright, nice future of what could this be useful for in terms of industry. On the other hand, it's like you said, there's so much skill and knowledge on construction sites that we don't
Mhm.
have. And our architects in school, you only learn so much and you can only gain so much experience from an internship or something outside. But we're actually talking a lot about it right now because we look at human robot collaborative processes and we're wondering, where does it make sense that a human with their skill and expertise comes in and aids the process? And we realize we can only guess because we're not the ones with the
Yeah.
great skill and expertise in construction. We know the things we try out in our lab, but we're not carpenters who have worked for many, many years and have gained very specific skills, or we're not specialists and in anything working with steel, welding, etc. So it is a bit of point where we're thinking about do we need to bring in people and see how they work with the material to see where would it make sense for a robot to add, or do we need
Mm.
to go on construction site and become those experts? I don't know. Those are questions on how to push this research forward. But there's definitely a need to link it more and to understand basically the skills and knowledge that is out there, the expertise that exists on construction site directly.
The risk
So
avoidance that architects traditionally have, around means and methods, and you're breaking down those barriers in school, right, by having the students and your research teams actually design and manufacture, build, fabricate
yeah,
these structures. And I think that needs to happen more, not less, but I don't know how that actually happens because the separation is so clear, right, between what architects and design teams do and what they're quote unquote allowed to do, all right, insurance wise. And you start to think about
yeah,
all the layers of stuff that is in between design and build. And
yeah,
obviously, some companies have done more in the realm of design build than others, but it's still like just looking at the big picture, there's a very clear kind of barrier there. And yet, like the opportunities that you're starting to identify or that you have been identifying in what's possible with the built environment, with the use of these tools, is so obviously exciting about, and I would assume exciting for both sides, because I can see why some people see this as threatening. And on the other hand, it's like there's so much opportunity of things that we've
yeah.
never been able to do before that, like you said, now that this thing can do this task for me, what if, right? It becomes the question. Well, let's find out. And I think that's obviously that's a huge, exciting aspect of the environment that you're working in every day. But getting that out onto the construction site, I mean, let's just talk about this for a second. When students get into the industry, if that's where they go, if they don't stay in academia, they are the ones who are listened to the least, right? And they have the exposure and they have these ideas and they understand the opportunity, the possibility because they've had this experience. And they're going out into a workforce where that does not exist at all and nobody wants to hear about it, right? Not nobody, but I'm totally generalizing, but for the most part. And so, like, how do we get more exposure? Maybe it's through podcasts like this, I don't know, but have you thought about that? It seems to me like you have a potential audience because you have a stage where you're teaching to bring in people from industry to expose them to it on both sides, on the construction side, but also on the architecture side and on the engineering side, to say, this used to not be possible. Now this is possible. And you need to know about it because there's graduates coming out of our program who know how to do this. Are you doing anything like that?
I mean, any collaboration with industry is a bit targeted to that, I want to say. Anywhere where we manage to bring in a company, whether they're a company of processing a certain material or construction, or whether it is more on
Mm-hmm.
the architecture engineering side. I think the goals for, like, the biggest win for us is exactly that, if they understand what's happening and how the possibilities are changing and what sort of knowledge we now have and the students that come out of here. It's a big hidden win because any collaboration is focused around the output and what are we developing and who brings in the money and what's where is this going. But I
Right.
think there's this very particular big win there. It's true, it's difficult. We educate the next generation and they're only at the beginning. And maybe in 20
Right.
years from now, they will be the ones calling the shots and be able to apply a lot of this. But it does feel like a very slow process. So, yeah, no, I don't have the right. I don't have the magical solution to that.
Right.
But that connection to industry is important for sure.
It is interesting to think about the students who are going to be in those positions in 20 years and how much robotics will have
Yeah,
changed in those 20 years that they haven't been
yeah,
using robotics, because
it's true. Yeah,
that's kind of a reality. And so it's just this really slow treadmill, right, that
yeah,
we're
yeah,
on of
yeah.
advancement. And there's a lot of waste in that. It's unfortunate. But I would imagine that there are some firms and some construction outfits out there who totally see the value in being a part of this now because it can differentiate them in a world that is heading more and more towards commoditized architecture and services, but also output. And so,
Yeah.
like you said earlier, you're in this luxurious position of being in academia and you get to be like the pundit of architecture. Guess what? Yeah, this is a great podcast to do that because we get to do that here too. You get to be critical of the profession because we love the profession and we want to see it improve and get better.
Yeah.
And these are the
Yeah.
conversations that need to be happening at a
Yeah.
broad scale. And so, do you have experience with companies, no matter where they're coming from, who do see those advantages and maybe just some examples of how they've been able to enable their business to do better by doing that, by engaging with you during the process so that they can excel in the market?
Yeah, so I haven't really worked directly with construction companies, for example, but I've seen a lot of projects that they were more targeted at the direct application and from my colleagues,
Mm,
basically. And I want to say
hmm.
in Switzerland, for example, the timber industry is
Right.
very interested in the digitalization process for good reason. And there's more and more companies that they build up their own little robotic labs. And they might not use those robots to build these unique geometries that have never been
Hmm.
done before 24 hours a day, but the machines are still used. So they find use for maybe more standardized construction too, but they have this possibility. A project comes in that requires more complexity that they can immediately set it up and do it. And I think there is a strong interest there. And it's not that unaffordable. Like these robots, sure, they're expensive for a private person, but they're not expensive in comparison to any sort of processing machinery. Like they're way cheaper than a good CNC mill, for example.
Yeah.
It's more the skills that are required to then program them to define what they do, etc. And those obviously they cost money and time.
Hmm. Hmm.
So that's a
Hmm.
little bit, I think that's the bottleneck in getting robotics more widely used in industries. Either requiring less skills to do it or having more people come out with those skills that can be quickly employed.
Yeah.
I think the feedback I've heard is that it's also really difficult for these companies to find the right people, which is fair. We educate a certain amount of students, but they also typically don't come out of architecture school as specialists in controlling
Mm-hmm.
robots. And there's usually just a handful that really might dive into it. It's not a saturated market there for sure.
Yeah.
Somehow, a lot of the maybe the teaching that we do is more here's an introduction and what are the potentials of it. And many students are excited about what the tools can do in terms of, oh, I can now design differently and I can think and generate of different things. But it's still quite a niche field for somebody to choose that as a career path and be like, I will be the specialist who can really control these machines and
Right.
build up a career on that. So it's not quite there yet in that sense.
Right. Well, it does seem like it is inevitable, though, because specialties, expertise doesn't have to be like full blown expertise. It has to be this
Yeah.
exposure to
Yeah.
it because this kind
Yeah.
of natural architectural mind that it is lifelong learning. They will continue to
Yeah.
develop and take in new inputs that they get exposed to outside of school, but then apply what they learned in school to that, and that saturation will happen kind of organically over time. There is some exciting possibility there for sure. But how
Yeah.
many students do you guys have going through your program that come out with what you
Um,
would, with a somewhat of an expertise in robotics?
so that changes from school to school, from context to context.
Mm,
And I want to say it's becoming more and more. Let's say, to put a number on it, it's a bit tricky, but maybe like, I don't know, 20 a year might have passed in like in a generic master's program, architecture master's program. Maybe it's 15, maybe it's 20. It depends a little bit on the year and the school and the capabilities. Like at the PFL, I'm one of maybe two professors who do
right,
anything with robotics and architecture. There's other schools where there's more going on.
right.
But I do know there's a shift, luckily, to introduce any sort of digital tools way sooner in education. So
Hmm.
there's schools that have they already teach programming, any sort of digital design, fabrication in at bachelor's level. We don't do that here yet much. There's a little bit going on, but not much. But other schools have really implemented this as like fundamental courses. Everybody learns Grasshopper, everybody learns a bit of programming, and everybody gets exposed to it really, really early. Which I think is a really nice shift.
Nice.
So yeah, in the long run, it's gonna be more and more and more. That's for sure. Right now,
Maybe,
I do still feel like it's a bit of a niche, but
yeah, for
yeah,
sure. I do see it though. In many schools have some form of a robot in their program. I don't
yeah,
know the
yeah.
utility, how much it's getting used, but I had
Uh,
Madeline Gannon on the show, and she talked about, finding a robot in the basement of a lonely robot in a dark basement, and right, and so sometimes that happens, right? The school gets the funding, they buy the machine because they have to spend the money to do it before
yeah,
their budget's gone, and then it just sits there because no one knows how to use it, no one knows what they want to do with it. But then there's somebody who comes along and is like, we're going to start using this thing, and I can imagine that is how a lot of robotics gets introduced into schools, whether they're architecture or engineering or whatever. But there are schools like yours that actually have a dedicated program, and people go to school there to learn that specifically. So there's also that also contributes to the lack of saturation in the market, right? That you're saying there's only 20 graduates per year. You can imagine as more schools uptake with this kind of a program, that's going to change things as
yeah,
well.
yeah, yeah. I do think it's like in anything, no economics. It's a balance between demand and offer, so to say, because
Sure.
we do, on the other hand, sometimes hear the critique that we're not preparing students well enough for the reality of an architecture office.
Right.
And I was like, yeah, we're not aiming for that because like we want to change that reality.
Yeah.
But it is only, yeah, it's always a bit of a question of how many, like, can they actually find a job with this, and the job that they're happy with the education we provide, or is it's yeah, the whole process moves hand in hand, right?
Right.
It's
It is interesting to think about academia being behind in that regard much of the time,
yeah,
which is exactly why the
yeah,
industry is taking so long to adapt and
yeah,
evolve, right? Because schools have traditionally trained people for the last version of practice, right?
yeah,
Which
exactly.
and it's interesting to hear you say, like, that's not what we're aiming for. We're aiming for the next version, right? So preparing students for what's coming, not where things have always been,
Yeah,
is I
yeah,
think a very refreshing view to hear, and I'm happy to hear it.
yeah, definitely.
So I think maybe last question here we can wrap up is, what is possible now that wasn't even possible like 5 years ago in robotics and architecture with what you're seeing?
I hate to think about where things were 5 years ago. It's not so long ago.
It isn't, but
And
COVID happened, and so it's also an eternity, right?
oh, yeah, it is an eternity. um, let's see what's possible that wasn't possible. Well, I do think access to both the knowledge and even just the hardware has become a lot easier in terms of I'm trying to think about where was I 5 years ago, and I was at ETH towards the end of my PhD. There were 4 robots in the hall and a handful of people who really understood the control and the software. And
Hmm.
now the same hall at ETH, I don't know how many robots it has because I stopped counting them, but I want to say 10 or something. A lot more. There's a lot more going on. Machines of different sizes. There's control software, open source control software that's been developed and that's reaching a point where, yeah, people can use it a lot easier. So the entry to actually using it is it's a lot more accessible. That I think would be the main change. And like you said, so many schools have a robot or several just sitting there. I think that
Hmm.
wasn't the same. Maybe 5 years ago, some had, but like 10 years ago, definitely not many schools had a robot in their basement. And right now, they all do. So there is an increase in the accessibility of the technology, which, yeah, I think enables a lot more to happen. There's also so many more people doing this type of work and research. Um, when I looked for a PhD position, I think around here I was only considering 2 schools as an option, and right now you could have there's yeah so many more that I could consider for my PhD. So it's definitely expanded quite quickly and given us given a lot more possibility to more people to do more research to build up on things. I do think it's also become more, on the one hand, more there's more in-depth research happening tackling really tricky technical issues, which maybe at the very beginning it was more about just make it work, make it
Yeah.
somehow do what you wanted to do. And now because there's a wider range of topics, of people, of knowledge out there, you can really go deep and solve something that's been nagging you for years and years, but you just never had the time possibilities to do. And on the other hand, there's also a lot more thought about the applications. There's also a lot more applied research connected to industry that's really going into industry, etc. So that's all abstract things that I'm listing just to say that a lot has happened,
Yeah.
definitely. And the impact is increasing, the range is increasing. Yeah, I think. And at the same time, if I can also like I give a bit of a critical outlook, it almost feels a bit saturated in the sense of what are we doing with this technology.
Mm-hmm.
So at the beginning, it was really exciting that we could build new forms and use different materials in different ways. And at this point, it's like, yeah, we've kind of seen it all. Or if we haven't, we know it's possible. It's just somebody hasn't yet implemented it, but they will in the next 5 years. So it is a bit of a changing point of what it's maybe not enough to just prove that we can do something, that it's possible,
Hmm.
but it's a point of really questioning what is this good for and what is the impact and where should we take the field so that it has a real impact beyond exploring new things that weren't possible before.
Yeah,
So that's
that's really great to hear because I think that is typically kind of a critical missing piece of the puzzle,
yeah,
which is what is the long-term
yeah, yeah,
trajectory that we're aiming for, not just the
yeah,
short term, like creating cool
yeah,
forms that were previously maybe unbuildable. I mean, all those are pieces of the puzzle, but like at the
yeah,
puzzle
yeah,
scale, at the big scale, where are
yeah,
things going and how can we help steer, get it to
yeah,
where the ultimate vision is? That's great to hear.
yeah.
The idea though of for students to,
Oh,
I think it's got to be so exciting to not only kind of, because of the tools that exist now that didn't exist, let's just go back 20 years or maybe
yeah,
25, right? the tools that exist now that enable the actual fabrication of the built environment through robotics to create very precise, that's probably a redundant way to say it. It's just precise. Constructability of an idea is got to be so satisfying for students to be able to participate in
Mhm.
that, from ideation to actual inception of that as a built thing. That, I mean, unless you took a construction class and you learned all that, and people have wood shops and they've got welding shops and stuff like that, but to go beyond those, that typical kind of construction, and create even going back to the pavilions, it's absolute, the thin shell pavilions, the carbon fiber pavilions, like the 3D printed pavilions. There's so many amazing things that are possible now. To see that happen in school is just got to be so incredible. To actually write the script, start with a sketchbook, write the scripting that then builds the geometry, and then you kind of reverse engineer the paths for the robot to follow to do the thing, and then actually do it, has got to be so amazing to go through, and such an incredible experience, a formative experience for architects of the next generation. So, I mean, that to me sounds super, super exciting.
Yep. I can subscribe to that. At least I was really
Right.
that generation that got to see that maybe first, or like between the first, one of the first generations to really see that happening. And I I think it was mind blowing. I constantly wonder if it's the same for my students today, or if because they've kind of seen a lot more of it, if it's not as exciting anymore. But I do think it is. I mean, you can see them when they, even the smallest thing that we do in a seminar here, a 2 hour a week sort of course, when they actually get to see the robot do what they wanted it to do from the beginning. I want to believe, I want to say I can still see it in their eyes that they're pretty blown away. So
Nice.
I'll I'll believe it's still happening.
Great.
Yeah.
Well, Stefana, I think that we've covered a lot of bases today, and I appreciate it. Is there anything else that we missed that you wanted to chat about or expose the audience to regarding what you're working on?
Oh, there would be many things I could talk on, but I think we're just for today.
Great. Well, I'll put links to everything that you're doing online, so people who are interested can learn more and learn more about you. And I really appreciate you taking the time to have this conversation today.
Thank you. Thanks a lot for having me.